In this session of metrology and instrumentation, we are discussing about transducers. People usually interchangeably call transducers as sensors because in any sensing element there will be an element which is interacting with external world to sense a physical parameter, and then it will be transduced to electrical signals. So there will be sensing part, there is transducing part also. So without sensing there is no transaction happens. So people usually interchangeably call sensors as transducers or transducers as sensors. In this session we will be discussing various aspects of transducers, static characteristics as one part, dynamic characteristics as another part, and we will be discussing classification of sensors as a separate session. In this part, we are discussing about static and dynamic characteristics. Characteristics of sensors means that explains the behavior of sensor under various conditions. Typically, we categorize the characteristics based on the dependency with the time. There are two kinds of characteristics. One is static characteristic, another one is dynamic characteristics. Static characteristics as the characteristics explained without relating it with time of operation of the sensor. Dynamic characteristics, these are explained by considering the behavior of the sensor during it is subjected to input signal or a stimulus. Why should we learn about the characteristics of sensors? Actually, these characteristics are very important when we go for purchase or select a sensor for certain applications. The applications can be when we do our experiment or when we do our project, when we develop a research test rig, or when we replace certain sensors. We should know what kind of sensor to be chosen and what are the features of the sensors to be considered for selection. So in that conditions, the characteristics of sensors becomes very important. Let us see in detail about static and dynamic characteristics. The meaning of static characteristic means these are time dependent characteristics, that is time independent characteristics. These features are used to characterize a sensor when the sensor is in static condition. That means the sensor is not being subjected to an input signal, or the sensor is in a stable state with an input signal. Examples of static characteristics are accuracy, precision, repeatability, etc. We will see these things in detail. Dynamic characteristics means the characteristics which are used to characterize the behavior of a sensor when it is being subjected to a stimulus or an input signal. That is, these characteristics are set with reference to a period, and the period is between the time of application of stimulus and the time that the sensor reaches its steady state. Steady state means the condition at which the output value given by the sensor stabilizes. So dynamic characteristics discuss about the behavior of the sensor when it is between the application, starting the application of sensing element, the stimulus, and reaching the steady state. Static characteristics speaks about when there is no signal or after reaching the steady state. Dynamic characteristics has some examples like speed of response, fidelity, measuring lag, etc. are few examples for dynamic characteristics. Let us more focus into static characteristics in this part. These are the characteristics that we are going to discuss in this session. Range means it is the maximum and minimum value within which the instrument can be used for measurement. Range is expressed by stating the lower and upper values that can be measured with that instrument. For example, take the case of a thermal sensor which is capable of measurement between minus 100 degrees Celsius to 100 degrees Celsius, then the range is said to be minus 100 to plus 100. Span is a similar term. It is the algebraic difference between the upper and lower range values of an instrument. In the previous case, we have seen that the range is minus 100 is a lower value, 100 is the upper value. So in this case, span is the algebraic difference between minus 100 and 100, then the span is 200 degrees Celsius. Range is a very important parameter when selecting the sensor, because take the case of measurement of temperature. If the measurement is to be done for your fever, human body temperature, then you choose a instrument which is capable of measuring temperature between say 20 degrees Celsius to 100 degrees Celsius. That is fine, it's more than enough, or even 50 degrees Celsius is more than enough. Then you go for a thermometer. But if your requirement is to measure the temperature during a machining process, where the temperature can lead to up to even 800 degrees Celsius, there you may have to go for another device. The thermometer will not work. There the range is different. You will have to go for a different device called as thermocouple or some other device. If it is a heat treatment furnace where thermocouple may not work, certain cases, there you may be going for a thermopile. So depending on the range of operation, the kind of sensor that you are going to choose to sense the same parameter temperature itself will be different. So the range of a sensor is very important, and that depends on your application. Accuracy is another term. That means it's a closeness of the measured value with the actual value or the true value. When we measure some value, we are nowhere aware what is the actual value that is available in the situation. Whatever given by the sensor is taken as the value for further processing, and that is a measured value. Error is actually, it is the difference, actually measured value minus true value is the error. So when you know the error, you can compute what is the true value for the instrument. An instrument, if it gives almost zero error, then we call it as an accurate instrument, or the measurement is accurate. Precision is another term where it is a capability of an instrument to provide the same reading repeatedly when used each time to measure the same signal or same input. It is also called as a reproducibility of the instrument. It is very important that we are measuring the same parameter with the same instrument under identical condition. Then it is, if it is repeated results are given, it is called as precision, precise measurement. When we discuss about accuracy and precision, often there is confusion or some misinterpretation. What is accuracy and what is precision? For clarifying these concepts, we have a typical example that is seen in many textbooks, and this is the case of a person who is shooting to a target. Say this is a shooting target, this is the exact point that we want to shoot, and this is the acceptable limit. So if we are taking the value, if the person is shooting at this point, and if all the bullets are falling on this region, we can say that this person is almost accurate in shooting. That is, all the values are about near to this. And if you take the mean value of all these dimensions, if you take the deviation from the center point, and the average may land up with the center point, so we can call it as an accurate shooting process. This is the case with the measurement process also, where if this is a required point, and if the instrument is giving this point or points around in and around this repeatedly, then we call it as an accurate process. Since all these measurements are given repeatedly within the range, we call it as a precise process also. Whereas take the case here, if we do a measurement for this particular true actual value, when the instrument gives this kind of values like this, then we can understand that these values are scattered. So obviously it is not precise, it is not giving repeated values, different values. But if you take the average of this, and if you take that, because it is a spread over the center point, if it is an average, if you take, if it will be falling almost near to the center, so we may claim it as an accurate process or accurate measurement process, but it is not precise because of scattered values. Here there is another case where there are points which are very close enough, but it is obviously away from the required point. If it is away from the required point, that away distance is called as the error. If it is if you take the mean value of all the scattered point and distance between that mean point and the center point, that is an error, typically called a systematic error. So in this process we can understand that this is not accurate, but it is precise. We have another case here If this is the required point, we have scattered values. Even if you take the average of scattered value, it will not land up here, it will be landing up somewhere here. That means there is an error. That means very high error even in the mean value. So it is not at all accurate. Being it is scattered, it is not precise also. So accuracy means how much close the result is to the true value given by the instrument, and precision means how much the instrument is capable of giving repeated value while doing the same measurement process under identical conditions. Another static characteristic is linearity. It is an ability of an instrument to show constant change in output for a defined change in input over a specified range. Take this case, here we have input, output. This is one measurement, say one kind of measurement, this is another kind of measurement. In all these cases, if you take the slope, that is, if for a particular change in input, what is the output generated, that's the slope is same, and here also the same slope, here also the same slope. So if you take the slope of this measurement process now entire range, that is from here to here, then it is seen that the slope is uniform. So it's a linear process, linear measurement process. This is also linear because here also the change in input and change in output, the ratio is maintained throughout the measurement process. So the ratio of output to the input, if it is a constant, then we call it as a linear measurement or linear measuring process. The slope is linear. Whereas non-linearity, it's actually an error. That means the ratio of output to the input is not a constant. That means the slope is not constant. Take the case here. Here, this is the expected linear result, but the instrument is giving some value like this, keep on varying. That means the slope is keep on varying. So such an instrument is called as a non-linear instrument. Any departure from the straight line relationship is called as a non-linearity error. If you can take the error, that is a non-linearity error. Non-linearity can be due to various reasons, like if the instrument involves some viscous flow, or the instrument has got some creep in the material, or if it has got non-linear elements in the measuring device itself, such as spring or something like that. If there is mechanical hysteresis due to residual stress or something like that, if there is elastic after effects in the mechanical systems, these are all few of the reasons that will cause non-linearity in measurement process. We prefer linear instrument because if you know the relation between input and output, if it is a linear instrument, the advantage is that over a period of range, if there is a variation in the output compared to the expected output, if it is a linear thing, we can very well understand that the measurement is erroneous or instrument is going erroneous. So if it is linear, if there is predictability for the output, in that case we can predict if at all some error happens. In the case of non-linear instrument, the predictability of errors is very difficult. Unfortunately, most of the instruments will introduce non-linearity error in the process, and good instrument manufacturers typically will represent what is the non-linearity error happening throughout the range. Sensitivity is another important characteristic, where it is a relationship between change in the output reading for a given change in the input reading. Sensitivity is the ratio of change in output to the change in input. Here you can see that we have many measurements. These are the main lines of the measurement. In this case, for a particular change in input, this is the output you get. Okay, so this is the output you get. That means uh, uh, that means here it is, this is the output you get, slope you get, whereas in this case if you have this is the input and this becomes the output, that is, for a given input the output is higher. That means in this case the output, that is a output part, if it is greater compared to the input, obviously the value will be higher, then we call it as a most sensitive equipment. So in this case it is a less sensitive equipment. Again, uh, non-linearity, linear sensitivity, that is, the change in output given by the instrument is different for sorry given by the instrument is different for constant change in input applied over a range. That means even if there is a change in our input, the output that is happening in the entire range, that is, this is a range of measurement where the slope can be varying, that like this. So this is an example for non-linear sensitivity, where the sensitivity varies. I'll give a typical example. You imagine that you are going to a petrol pump to fill petrol in your bike, say for 100 rupees. Now, if the tank is empty, even if you fill petrol for 100 rupees, the gauge reading may not show appreciable variation. That means for a particular input of petrol, the variation shown by the instrument is little uh, uh, not that good. Whereas if there is half petrol in the tank, and if you are filling for the tank with the same 100 rupee, the same amount of obviously fuel will be filled in there. But in that case, you can see that the change in meter reading will be more compared to the change in meter reading given at the beginning. That means the gauge is showing non-linear sensitivity in the lower range compared to the upper range. In the upper range it is more sensitive, and the lower range it is low sensitive. It is an example that we are feeling. So we know that if the instrument is having linear sensitivity throughout the range, it will be very easy to assess if there is an error in the performance. But if it is non-linear, it will be very difficult to assess the error in the performance of an instrument. So these are few examples of non-linear. Say these are sensitivity curves, and here there is one kind of sensitivity. Here the sensitivity is higher at the beginning, here the sensitivity is lower at the beginning. Here the sensitivity keeps on varying like as a slope. So that is non-linear sensitivity. Threshold is another characteristics, that is the minimum value of input required by the instrument to give a detectable output from zero value. Certain instruments, even if you apply certain input value or some signal, the system will not respond. It will start responding only after a while, or after applying a particular value of the input parameter. That minimum value required to start detecting for the sensor is called as a threshold value. Here this is the threshold value. Hysteresis is another parameter. This is the algebraic difference between the value shown by the instrument when the instrument is used for a measurement in opposite directions. That means, say this is the value, input value, and we are expecting this output here. Okay, this is some output. If it is a linear one, we expect an output here. But if the instrument is giving an output for a particular input here, when we increase the value of the instrument, say if you measure the temperature of some particular point, and if you use a thermometer, if it was at 0 degrees Celsius, and the 0 degrees Celsius will be increased to reach here, instead of showing this particular output value, the instrument is showing this value. Say this is case number 1. Imagine that the thermometer was already heated to this position. Now you are trying to measure the same temperature here. While cooling back, if it is showing this temperature, then we can understand that for the same measurement value, the instrument shows one value in one direction and another value in the opposite direction when it is measured. Such a phenomenon is called as hysteresis. It is the non-coincidence between the loading and unloading curve it is called as hysteresis. There are many reasons for hysteresis. It can be because of mechanical friction, it can be slack motion in bearings, backlash, residual magnetism, residual stress, etc. are few of the reasons for hysteresis happening in measurement instrument. Resolution is another characteristics. It is the smallest change in input that can produce detectable and quantifiable output. Least count of the instrument is taken as the resolution in many cases. Reproducibility. It's the ability of an instrument to reproduce the same value when measuring a parameter under identical measurement condition. Reproducing the same value under same measurement conditions. Another parameter is stability and drift. We can say that drift is opposite to stability. Okay, stability means it is a capability of a sensor to retain the produced output over a period of time when a constant input is given. Drift, if the produced output cannot be retained, okay, then we call it as drift. That means if the produced output given by the sensor changes even while there is no change in the output over a period of time, then the error is called as drift. I'll give an example. You go to the jewelry shop. You are trying to buy one ring, say of 8 grams. You are placing the the 8-gram ring on a pan, and you are waiting. What is the weight for that? Okay, it is showing some 8.01 grams. Okay, you are waiting there, and if it is maintained in that particular value, then we can say that it is stable, it is stabilized. So 8.1 gram is the weight of that particular ring. Imagine a different case, that is, if you place the same ring over there and if it is showing 8.1 gram now, and by the time the evaluator, the person, the salesperson, he usually writing the values in the paper. After stabilization, if you see that, if it is changing the value, say if it is changing to 8.1, instead of 8.1 it is showing 8.120 grams, that means 0.01 gram changes. After a while again it is changing to say 8.200 grams. That means even after stabilization the instrument is not capable of retaining the value, and that change is called as drift. Now it's time for a review. Please verify if you can distinguish between static and dynamic characteristics of measuring instruments. Can you define the following terms: hysteresis, drift, resolution, threshold, etc. with suitable examples? Can you describe the terms sensitivity and non-linearity of an instrument? If it is yes, good. Otherwise, please go back and check and learn it, and let us proceed to the next session of dynamic characteristics once you complete that part.